Hi friends. So today I'll take another lecture which is a very basic or let's say a fundamental of what is geography is, and then what are the latitude, longitude, basic interior of earth, like this type of topics which are very basic and very fundamental, which we had already learned in our like 6 7 standard. So I'm just covering that, trying to hope that it will cover a basic fundamental. So let's start. So basically, if we let's say earth, there is earth actually, because we are living in at earth. But uh, if we try to imagine like our maps, like this 2D maps, where length and just one length and one breadth is there, just 2D. But we have a spheroid shape. In previous lecture, in earlier lecture, we had discussed that earth is a geoid, means a specific shape, uh, a very specific shape attained or very specific shape assigned to the earth is geoid shape, or or let's say spheroid shape. So this is our, let's say, spheroid, bulkier at the equator and just somewhat uh, patch in polar. So like not that word, but simply some uh, means flatten at the pole. Likewise, flatten at the pole, and here it is a bulky. That is our shape of our earth where we are living. So how, for example, if I want to locate one point on earth, let's say I want to locate my position, like GPS, global positioning system, then how that GPS is working actually? Basically, that system technology actually uses the geographical knowledge. There are various branches of geography, like meteorogeography, like sorry, no, not the thermogeography, but various types of geography. There is a list, a whole bunch of list is there in the geography section. There are so many geographies. So if I consider Earth and I want to locate one point here, what should I do that I can able to locate this point? I have to draw a vertical line. I have to draw a horizontal line. So this point is specifically located in 2D sphere, 2D sphere or a 2D plane. But if it is a 3D, then I have to draw third axis also. So to easy this task, or to locate the our countries, our oceans, all this stuff, we introduce imaginary lines. So this is our Earth. This is equator 0 degree, and we introduce imaginary lines like this. These are called latitudes. These are called latitudes, and there are horizontal vertical lines are there. These are called longitudes. So why these are important? Because our, as we all know that our Earth rotates from west to east. The rotation of Earth is basically from west to east. So the point here, if I suppose a point A here and if I suppose a point B here, I'll do some mathematics basically and try to indulge you into this topic by using some simpler logical phenomena. Let's say sunrise is there, sun is there, sun is there. So let's say if my Earth rotate like west to east, then sun ray will directly first come to A point, and after some time, after few hours in our clock, it comes to the point B. Correct? It comes first at a point A and then comes at a point B after some time. So there is a gap in time. So how one could understand that gap? For example, here it is a 9 a.m. Then at the same time, here it is something x a.m. I'm not disclosing what the time is here because I'm first telling you what is the logic behind it, and after that I will tell you the math behind it. So let's first, and most important, this is GMT line, Greenwich time, where all the time we are considering from this as a 0 point, zero time point, from where we are considering all our timelines. So basically longitude, remember this, longitudes decide time and date. Longitudes decide time and date. How? I'll tell you. Let's say this is my earth, a 2D earth. This is my zero line, prime meridian line. And if I go further and if I go behind it, behind in the sense, if I go westward and if I go eastward, then what should happen? By common sense, if I go ahead, then for example here there is a 10 a.m. and if I go ahead, that means I'm reaching sun rays more early than this point. That means this is something t plus 10 plus t time is there. 10 plus t time is there because I am reaching that point earlier. Correct? And if I go westward, then I am running away from the time, means sun rays are falling after this point. After this point means at my clock it is 10 minus t. And if I imaginary line, if we know the distance between this time and how much velocity earth is rotating, then velocity is distance upon time, then we can calculate time easily. Then we can calculate also what should be the let's say that t, what should be the t, what should be the other things. But for sake of simplicity, I am telling you that 15 degree is equal to 1 hour. 15 degree is equal to 1 hour. Why this time has come? Let's do some math here. Because if I draw, I'm drawing here small earth, small longitudes and latitudes. Let's calculate the number of latitude and number of longitude and then figure it out how we can find out time and date. Let's do it. For example, I have latitudes and I have longitudes. So first we will calculate latitudes. Angle and number. So for latitudes, how one can find out the latitudes? This technique. So this is prime meridian, this is center C, this is 0 degree equator. If I draw a line here, this is 10 degree, 10 north. Remember this north is very important. If someone write here east, then it is totally wrong because this is northward, this is southward, this is westward, this is eastward. So this is north. So if I draw up to 90 degree, then there are total 90 plus 90, total 180 angles. But this 0 degree equator is one angle, that's why it is 181 total angles. So angle is 181 angles, not degree, number of angles. And how much line should be there on the sphere? Let's again try to do it. Let's do it. If I consider 1 to 90, 1 to 90, again 1 to 90, and this 0 is there. So here come, but I'm counting 1 twice. That's why I have to, sorry, I'm counting 90, 90 twice. So just 180 minus 2, which is 179. So number of lines are 179 and number of angles are 181. So why I'm doing this stuff, why I'm calculating this? Because I have to find out 15 degree is equal to 1 hour. How it could be possible that 15 degrees 1 hour? 15 degree means these are my longitudes. 15 degree, 30 degree, 45 degree, then so on and so forth. So if I go ahead and go ahead, sorry, not ahead. If I go eastward and go westward, then 50 degree add a 50 degree subtract. So just try to, I'm thinking right now how to calculate. Let's say I have a latitude. Okay, I have to calculate longitude also, because time is figure it out with the help of longitude, not the latitude. So just keep it aside, this part. I'm calculating here longitudes. So this is longitude. So this how many are there in this figure of Earth? 360 simply. So if 360 lines is equal to 24 hours, then I have to find out 360 degree is equal to 360 degree line is equal to 24 hours. I have to find out how many degrees, how much hours. So one hour is 360 divided by 24. If you calculate this, if your math is enough strong or enough pretty much good, then it is come out to be 15. So 1 hour is equal to 15 degrees. That's it. So this is a simple math behind how the time is going in the future, and how the time, sorry, not in the future, eastward and westward. Sorry, eastward and westward. So this is all stuff. So I'm just wipe it out because I have to go further. Then comes some terminologies, like our earth is there. There are ocean, there are continent, there are island, there are peninsula. So I'm writing one by one and then define it. So first is island. Then continent. And peninsula. These three are the nothing but landmass. Landmass. Island is nothing but a land body surrounded by water. Continent is large land body surrounded by water. But peninsula is a land body which is surrounded by water, same as a continent, but there is a one slight difference. In peninsula, there are only three-sided water is available. Means, for example, India is surrounded by Arabian Sea, then Bay of Bengal, and Indian Ocean. So this is India, the southern part. Southern part is surrounded by three water bodies. So that's why it is peninsula. So that's peninsula. Then we will talk about little bit what is straight isthmus, because these are some of the important feature. If you saw the map, you'll already know it. Straight. Straight means, for example, this is a water body. This is water body 1. This is water body 2. So straight is nothing but a water body which connects two water bodies. That is a straight. And what is isthmus? Isthmus is nothing but a landmass which connect two land masses, or a landmass which disconnect two water bodies. That is our isthmus. I'm just speeding up because this is very fundamental concepts. Then I'm writing some of the name of continent, because this is a very basic lecture, so don't expect 7 continent is there. First is Asia, then Africa, then Europe, then Australia, then South America, North America, Antarctica. These are 7 continents, and there are 5 oceans. First is Pacific, second is Atlantic, third is Southern Ocean, fourth is Arctic, fifth is our Indian Ocean. So that is a very basic information. So this is up till now we discuss some of the main definition, math behind. If we go eastward, if we go westward, what will happen with respect to time. And there is also one concept, international date line, ideal. Ideal is there. This is a very zigzag line somewhere. I'm not drawing as it is showing in the book. But if you go eastward, there is a decrement in the date, and if you go westward, there is an increment in the date. That's a simple concept. You have to just remember, mug it up or remember by conceptualization that. But just one thing to remember is that 1 Jan means if I go here to here, then I'm not losing the day, I'm gaining the day. 1 Jan to 2 Jan, if I flight from here to here, if I do flight from here to here, then I'm gaining day here and losing day here. So that's a very common sense. Then comes what remains, Indian Standard Time. So basically Indian Standard Time passes through Odisha, Madhya Pradesh, Andhra Pradesh, Chhattisgarh and UP, Uttar Pradesh. So these are some of the facts. I'm just collecting some of the information and showing you as very fundamentals of geography. In further lecture, I'll try to include tectonic plate theory, seafloor spreading, then continental drift theory. There are so many beautiful theories and so many great scientists over there, and we'll talk about it later. Thank you.